Hello friends, have you ever wondered if humans are the only smart beings in the universe? Or could there be other intelligent life forms out there? If aliens exist, they might be asking the same questions we do. Are they alone in this vast universe? How can we communicate with them if we ever find them? With these questions in mind, NASA has launched many Voyager missions aimed at sending messages to any potential aliens. In this video, let's dive into the fascinating story of the Voyager missions. It all started in 1965 when a NASA engineer discovered something exciting. He noticed that the last four planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, would align in a unique way in the late 1970s. This special arrangement happens only once every 175 years. This means a spacecraft could travel using the gravity of these planets to save fuel and time. This technique is known as gravity assist, which allows a spacecraft to change its speed and direction by flying close to a planet. Based on this idea, NASA made plans for two spacecraft, Voyager 1 and Voyager 2. They decided to launch these missions in 1977. Voyager 1 was designed to fly past Jupiter and Saturn, with a special focus on Saturn's moon Titan. Voyager 2, on the other hand, would visit Jupiter, Saturn, Uranus, and Neptune. Both spacecraft were built quite similarly. They were powered by three radioisotope thermoelectric generators. Unlike many spacecraft that use solar panels, Voyager missions couldn't rely on solar energy after passing Mars and Jupiter because the sun's rays are too weak at that distance. Instead, they used the heat from the decay of plutonium to generate electricity. This heat from radioactive decay is converted into usable energy, which is why it's called a radioisotope thermoelectric generator. In addition to the power sources, both probes carried 10 scientific instruments. These included a two-camera system for taking pictures, a spectrometer to measure hydrogen levels, another spectrometer to observe ultraviolet activity, and a magnetometer for measuring the magnetic fields of the planets. They also had a high-gain antenna to communicate with Earth, along with several smaller instruments to measure radiation levels. Interestingly, Voyager 2 was launched first on August 20th, 1977. Voyager 1 followed 16 days later, launching on September 5th, 1977 from NASA's Kennedy Space Center. Even though Voyager 2 launched first, Voyager 1 took a shorter and faster route. This meant Voyager 1 arrived at Jupiter before Voyager 2. In March 1979, Voyager 1 sent back stunning images of Jupiter taken over time. It captured this incredible time-lapse using 66 different photos, each taken after one of Jupiter's rotations, which lasts about 10 hours. This was the first time we saw such clear images of Jupiter and its moons. During this mission, we also discovered that Jupiter has rings, just like Saturn. Many people believe only Saturn has rings, but Jupiter's rings are there too, though they're not very visible from afar. The group of Jupiter, its moons, and its rings is known as the Jovian system. The term Jovian comes from the Roman god of sky and thunder, Jove, who shares a name with Jupiter. In our solar system, there are three other planets like Jupiter, Saturn, Uranus, and Neptune. All of them have rings and many moons, which is why they are called gas giants or Jovian planets. While exploring this Jovian system, Voyager 1 made a groundbreaking discovery that found that one of Jupiter's moons, Io, was volcanically active. This was the first time we saw active volcanoes on another celestial body. Before Voyager 1 arrived at Jupiter, we thought there were 13 moons orbiting it, but once it got there, we found two more moons. On July 9, 1979, Voyager 2 reached Jupiter and got even closer, allowing us to discover another moon. Because of these missions, the total number of known moons around Jupiter increased from 13 to 16. But here's an amazing fact. Scientists have since discovered 95 different moons orbiting Jupiter. That's right, 95. About a year and a half later, on November 12, 1980, Voyager 1 flew by Saturn. By then, Voyager 1 was traveling much faster than Voyager 2. Voyager 2 took 9 more months to reach Saturn. Once Voyager 1 got to Saturn, it discovered 3 new moons: Atlas, Prometheus, and Pandora. Interestingly, Pandora is the name of a fictional alien planet in the movie Avatar, but it's also one of Saturn's moons. At the time of the mission, about 15 moons of Saturn were known now. Scientists have discovered around 146 moons. Voyager 1 took many incredible photos of Saturn and its moons, including Titan. Titan is especially interesting because it is the only other place in our solar system besides Earth that has clear evidence of liquid water. This is why many science fiction stories imagine Titan as a potential home for aliens or future human colonists. After passing Saturn, Voyager 1 and Voyager 2 took different paths. Voyager 2 continued on to Uranus and Neptune, becoming the first and only human-made object to fly by these planets. It reached Uranus in 1986 and Neptune in 1989, sending back amazing photos. Meanwhile, Voyager 1 changed its trajectory and left what is known as the ecliptic plane. The ecliptic plane is an imaginary flat area where all the planets in our solar system orbit the Sun. Although the orbits vary slightly, they mostly lie flat. Voyager 1 flew above and beyond this plane, moving incredibly fast due to the gravity assist it received from the planets. Today, Voyager 1 is traveling through space at more than 60,000 kilometers per hour. To give you an idea of where both spacecraft are now, Voyager 1 is currently about 25 billion kilometers from Earth. On January 1, 1990, Voyager's Interstellar mission officially began. The goal was to go beyond the Sun's influence. Then, on February 14, 1990, Valentine's Day, Voyager 1 took a famous photo known as the pale blue dot. This image was captured when Voyager 1 was about 6 billion kilometers away from Earth. In it, Earth appears as a tiny blue dot. From this distance, Voyager 1 took a family portrait of our solar system, capturing Venus, Earth, Jupiter, Saturn, Uranus, and Neptune all together. However, Mercury and Mars are not visible because of the Sun's glare, and Pluto is too small to be seen. After taking these last images, Voyager 1's cameras were turned off to save power. At this point, there was nothing else significant to photograph in the dark of space. Voyager 1 was headed into the depths of interstellar space, and for many years there were no updates from it. In 1998, Voyager 1 made headlines again when it became the farthest man-made object from Earth. Then, in 2004, scientists announced that Voyager 1 had crossed a boundary known as the termination shock. This is the point at the edge of our solar system, where the solar wind, a stream of charged particles from the Sun, suddenly slows down. So what is solar winds? These charged particles create a bubble around our solar system, known as the heliosphere, which protects us from radiation from space. When Voyager 1 reached the heliopause, the outer boundary of the heliosphere, the solar winds became weaker. On August 25, 2012, Voyager 1 made history by leaving the heliosphere and entering interstellar space. For the first time, it took 22 years for Voyager 1 to reach this boundary. NASA spent 8 months confirming this monumental event, carefully checking the data, and finally announced in September 2013 that a human-made object had crossed the solar system's limits. How did scientists know Voyager 1 had crossed this boundary? They used its plasma wave instruments. Between April 9 and May 22, 2013, a powerful solar eruption was detected by Voyager 1. This eruption caused electrons around Voyager 1 to vibrate. Researchers noticed that the electron density was much higher compared to when Voyager 1 was still within the heliosphere. This difference told scientists that Voyager 1 had indeed entered interstellar space. You might wonder how it's possible for electron density to be higher outside the solar system. The answer lies in the solar wind. When Voyager 1 was at the heliopause, the electron density was low due to the weak solar wind. But once it entered interstellar space, there was a sharp increase in electron density. The data from Voyager 1 was transmitted back to Earth using its high-gain antenna, which communicated with NASA's 3 Deep Space Network stations located in California, Madrid, and Canberra, Australia. These stations are crucial for receiving data from distant spacecraft. After receiving the data, researchers calculated the exact date Voyager 1 crossed into interstellar space, confirming it was August 25, 2012. Coincidentally, this was also the day Neil Armstrong, the first human to walk on the moon, passed away. While we were focused on Voyager 1, what about Voyager 2? Voyager 2 entered interstellar space 6 years later, on November 5, 2018. Both Voyager spacecraft are the only 2 to have achieved this milestone. They are also carrying messages intended for aliens. Although both Voyager missions have set many records, they weren't the first spacecraft to attempt to send messages to extraterrestrial life. In 1974, scientists sent a signal called the Arecibo message from Puerto Rico. This message contained information about human DNA and the structure of our solar system, among other details. However, the Arecibo message was just a short radio signal sent to a star cluster about 25,000 light-years away. In contrast, the Voyager spacecraft carried a gold-plated phonograph record designed to last billions of years. This record contains sounds and images meant to represent life on Earth, including greetings in different languages, music from around the world, and natural sounds like thunder and bird songs. The record was created by a team led by Carl Sagan, who wanted to make sure that if anyone ever found it, they could understand it. It even includes a simple map showing where Earth is located in the Milky Way galaxy. This is an ambitious effort to make contact. In 1977, both Voyager 1 and Voyager 2 were equipped with these records before they launched. Each record has 115 images, including pictures of people, animals, and nature, along with various sounds. For instance, one of the songs included is Johnny Be Good by Chuck Berry. The team carefully selected the content to represent the diversity of life and culture on Earth. So what happens next for Voyager? Currently, both spacecraft continue to travel farther into interstellar space, sending back valuable data. However, they are slowly losing power. Scientists estimate that by 2025, they may no longer be able to send signals back to Earth. Even if Voyager missions stop transmitting data, their legacy will endure. They are a testament to human curiosity and our desire to explore the universe. We may never know if someone out there received our messages, but thanks to the Voyager missions, we took a brave step toward reaching out to the cosmos. In conclusion, the Voyager missions are not just about exploring our solar system. They symbolize humanity's search for knowledge and connection beyond Earth. From discovering volcanoes on Io to capturing the stunning pale blue dot image, these missions have reshaped our understanding of the universe. They remind us that we are part of something much larger, filled with wonders yet to be discovered. As we continue our exploration of the universe, may we always keep looking up at the stars, asking questions, and dreaming of what lies beyond. Thank you so much.